So our last section in this unit is going to be on absolute value functions and their transformations. And we've already looked at the absolute value function a couple of times this year, once when we were just reviewing all of our parent function graphs, and then earlier in the year when we were talking about function notation. So hopefully this one is a review for you, but the absolute value function, just like any other function, can be graphed using some points that you choose for x and y. And again, you could choose any values you would like for x and y, but I'm going to just choose a few positive ones and a few negative ones, because unlike the square root function, we can take the absolute value of a positive or a negative integer value. And so, or a positive or negative number of any kind for that matter. But I'm going to stick with just a couple of negative numbers and a couple of positive numbers. I'm going to spread them out just a little bit instead of doing some that are really close together. So I'm going to use -4, -2, 0, 2, and 4 for my anchor points. So all I have to do for my y values is put these into the parent function. The absolute value means the distance from 0, and so the absolute value of -4 is going to be +4. Absolute value of -2, +2. 0 is 0, 2, 2, and 4, 4. So that gives me some points that I can graph. So -4, +4, -2, +2, 0, 0, +2, 2, and 4, 4. And so we get our absolute value graph. All right. And so, as we can see, the domain is going to be continuous, all real numbers, or -infinity to infinity. And our range is going to start at 0 and go up, so 0 to infinity. And we're going to do all of the same changes that we did to our other parent functions in our last lesson. So in this first problem, they want us to take this function and shrink it by a factor of 1/2. So we know that the shrink is going to go in front, reflect across the x-axis, so that means we're going to make it negative, and then we're moving it to the left too, which means that's going inside the parentheses with x. So here's what we're going to have. Y equals -1/2, reflect in 1/2, and then we need to identify our parent function and move it to the left. So x plus 2, but we've got to identify the parent function, so that would be the absolute value. You do not have to have both the bars and the parentheses. If you want, you could just put the bars, but you have to identify the parent function, and they kind of work as your parentheses. So this is our left shift. All right, then we're going to make those changes to x and y like we did before. And so anything on the outside we do to y. So we're multiplying y by -1/2. And for the x's, we're doing the opposite of what this says. So we're going to subtract 2. So let me see if I can get, yeah, we can see them all up here. So if I have -4 and I subtract 2, I get -6. -2 subtract 2, -4, 0 subtract 2, -2, 2 subtract 2, 0, and 4 subtract 2 would be 2. And then for our y values, we're going to multiply by -1/2 or divide by -2. So 4 divided by -2 or times -1/2 would be -2. And then 2 times -1/2 or divided by -2 would be -1. 0 would be 0. And then we have 2 again and 4 again. And so we have our points that we can now graph. So we've got -6, -4, oh, sorry, -2, -4, -1, -2, 0, 0, -1, and 2, -2. And And so our new graph is a shrink of 1/2 reflected across the x-axis and shifted to the left. So our domain is still going to be negative infinity to infinity, but our range now starts at the bottom at negative infinity and goes up to 0. All right. And then we have another one of those. This time they want to take our parent function and stretch it by 2, move it right 1 and up 2. So the stretch goes in the front, right and left go inside your parentheses, up and down go on the end on the outside of the parentheses. So we have y equals 2, absolute value, and if you want to include the parentheses inside, x, and then right 1 would be minus 1. Close out your parentheses, and then up 2, plus 2. All right. So for our x's right here, the things inside are what we're doing to x. So we're adding 1 to our x's. So I'm going to slide this back down. So if I add 1, this would be -3, -1, 1, 3, and 5. Let's put those down here. Adding 1, -3, -1, 1, 3, and 5. Okay, then for the y's, we're supposed to multiply by 2, and then we're going to add 2. All right, so multiplying by 2 and adding 2. So 4 times 2 would be 8, plus 2 would be 10. 2 times 2 is 4. Add 2, we get 6. 0 times 2 is 0. Add 2, we get 2. 2 times 2, 4. Add 2, 6. And then 4 again. So this one would be 10 as well. All right. And so we regraph. We've got -3, 10. -1, 6. 1, 2. 3, 6. And 5, 10. Okay. And again, our domain, still all real numbers. Our range this time is going to start at 2 and go to infinity. So hopefully we're getting pretty good at these transformations and changing our charts. And our charts, remember, depend on what parent function you're starting with, what parent function you're given to create your values here. Okay, so on the back, we are changing gears here a little bit. What we're doing on this page is they're going to give us the graph of a function, and then we're going to try to write the equation that goes with that function. So we need to first, I think, go through and make sure we can identify the shape of the parent function. And so this one, the shape of this with this little curve that starts here and moves on to the right towards infinity, that one is our square root function. And I'll come back and fill that in. This one that looks kind of like a V, this one's just upside down, would be the absolute value function. This one and this one look very similar, but we talked about this whenever we were doing the one that had finite stopping points. This one, although they didn't draw it for us because they want us to know, they want us to recognize, this one is going to be my parabola, and I know for sure that it's a parabola because it's been shifted left and right. And we talked about the fact that a parabola can move left and right, but this one, which is going to be the semicircle function, can't move left and right. So this one is our parabola, so it's going to be a squared function. And this one is going to be that semicircle equation. So remember, it's our radius squared minus our number squared, our radius. I guess I should call that x. All right, so now that we know what they all are, I want to go back and put the transformation equation with each one of these. So let's start with this one up here. Our transformation says that we could have some shrink or stretch out in front, and then we identify the parent function, which in this case would be a square root function, and then inside, if we have a left-right shift, it's going in here, x minus h, and then on the outside, we're going to have our up-down shift plus k. The same thing would be true here with our absolute value. I guess I need to spread that out just a little bit because we could have y equals a times, and then inside here, if we have a left-right shift, it would go inside plus k for our squared function graph. It's x minus h squared plus k. Same equation. So that's my point. They're the same thing over and over and over again. The only thing changing is the type of parent function we have. This one is the only one that's not going to have h in the formula because we cannot shift this graph left and right. It would just be y equals a times r squared minus x squared plus k. It can only have a shrink stretch and an up-down shift. All right, so what we're going to do here is try to figure out where the graph has moved. We are not going to worry about the shrink or stretch because we can use this point that they give us to find that information. All we need to do is figure out whether it's been moved left and right, up or down. So in this case, this is the point at which we used to have our graph starting at the origin. So we can tell that this thing has been moved to the left 3 units. And so if I want to move this thing left 3, then I want to put a plus 3 in here for h. So we have y equals a times the square root of x plus 3 under our root. And it wasn't shifted up or down, so that's going to be it. And now we can plug in x and y just like we did the other day to find out our shrink or stretch. So we're going to put 4 in for y and 1 in for x. So we end up with 4 equals, and this is 1 plus 3 is 4. Take the square root is 2, so we have 2a. Divide by 2, so we get a is 2. So our equation would be y equals 2 times the square root of x plus 3. So here's the order we're going to do this in. Look at your parent function. You may need to look back at your original parent function graphs if you don't remember where they used to start. But this one started at the origin, so we moved left 3. So that's the first thing you want to figure out. Figure out where you want to put this. We're putting it in for h. Put that in your equation, and then use the point to solve for a. All right, so in our next one, the most important point to be looking for is where that vertex, where that point used to be. And that point used to be here at the origin. So that point has moved to the right 1, and up 1, 2, 3, up 3. So we're going to have a number in here for h, and we're going to have a number in here for k. So we have y equals a times the absolute value of x minus 1, that would be the right one, and then plus 3, up 3. All right, so this time they were not quite as kind to us with the numbers that they gave us for our point, but it still works the same, and if you have a calculator, you may want to grab it. We're going to put 2.6 in here for y equals a times the absolute value of negative 0.6 minus 1 plus 3. So we have 2.6 equals, this is just negative 1.6, but then we take the absolute value, so positive 1.6a plus 3. All right, then we're going to subtract the 3. And so 2.6 minus 3 is negative 0.4 equals 1.6a. And so now we're going to divide, and again, if you have your calculator, you are more than welcome to use it, but remember that both of these have one decimal place, so this is really just like dividing 4 by 16. 4 over 16 would just be 1/4, but you're welcome to grab your calculator, divide by 1.6. So A should end up being negative 1/4 or negative 0.25. All right, and so we have our equation, y equals negative 1/4 absolute value of x minus 1 plus 3. All right, next we have our parabola. So here's our formula for the parent function. This one, the vertex used to be at the origin, so it's moved to the right 1, 2, 3, 4, right 4, and down 1. So we're going to have y equals a times, and then right 4, so we have x minus 4. Parent function is squared this time, and then down 1, minus 1. So now we're going to plug in the point that they gave us. So we have 3.5 equals a times 1 minus 4 squared minus 1. 3.5 equals 1 minus 4 would be negative 3. Negative 3 squared would be 9. So 9a minus 1. Add 1 to both sides. So when I add 1, I'm going to get 4.5 equals 9a. Divide both sides by 9. So a equals 4.5 divided by 9 is just 1/2 or 0.5. So we have y equals 1/2 x minus 4 squared minus 1. Last one. Now this one, sometimes people have a little bit of a hard time, but for those of you that are at home and not in class, we talked about that these 2 points are really the important points on the original graph of that semicircle. Remember, on the original graph, the parent function sits on the x-axis. So these 2 points, these 2 finite finishing points, are the points that really are moving. So what we need to do is figure out where these 2 have moved, and these have moved up 2 units, up 2. All right. Now, we already said there's no left-right shift on this one, and to find a, we're using our point, so that's all we need to know that it moved up 2. We know that it also flipped over, but we'll figure that out. That just means our a value is going to be negative. So we're going to have y equals a times, and then we are going to have to identify our parent function. And over here, we put an r because it could be any r value, but this one has a radius, or the distance from your y-axis out is 3. The radius is 3 units. 1, 2, 3. 1, 2, 3. So 3 squared would be 9 minus x squared. And then we have our shift, which was up 2. All right, now they gave us some really terrible numbers here, but grab that calculator. We're going to put in negative 5.2 equals a times the square root of 9 minus negative 1.8 squared plus 2. All right, so we have negative 1.8 squared is negative 3.24. So Negative 5.2 equals a times the square root of 9 minus negative would be plus 3.24 plus 2. So 3.24 plus 9 is negative 12.24. Nope, that's not right. So negative, right here, a negative squared, I should have put that in parentheses, is going to be a positive 3.24. So we're subtracting a positive 3.24. So let's try that again. So 9 minus 3.24. 9 minus 3.24 is going to give me 5.76. And the square root of 5.76 is 2.4. So let me show you my calculations here. 9 minus 3.24. Then we take the square root of 5.76 is 2.4. So negative 5.2 equals 2.4a plus 2. Subtract the 2. So negative 7.4 equals 2.4a. Oh, there's another one. 5.2 minus 2 is negative 7.2. All right, then divide by 2.4. Divide by 2.4. And a equals negative 7.2. 2.4 is negative 3. Negative 3. All right, so our a value there, we knew it had to be negative because this thing was flipped over, but our a value is negative 3. So we have y equals negative 3 times the square root of 9 minus x squared plus